Cool. A virus is spreading rapidly, and your task is to quarantine the infected areas by installing walls. This is 749 contained virus. Um, the world is modeled as 2D arrays of cells, where 0 represents uninfected cells and 1 represents cells contaminated with the virus. A wall and only one wall can be installed between two four direction any two four directionally adjacent cells on a shared boundary. Every night, the virus spreads to all neighboring cells in all four directions, unless blocked by a wall. Resources are limited. Each day, you can install walls around only one region. The affected area that find the most uninfected cells the following night. There will never be a tie. Can you save the day? If so, what's the number of walls required? If not, and the world becomes fully infected, return the number of walls used. Okay. Uh, okay. So I mean, I think this is just simulation. Yeah, and each only 50 elements. So you can so yeah. So first thing I generally look is kind of like think about constraints, and in some cases in the past, or like today, I mean, they just were very lax on those constraints. So 50 by 50 is this very small grid. Um, Probably do like an n to the fourth thing, and where n is the one side and not or and what this also means is with simulation is that at most, if you progress in a Manhattan distance kind of way, uh, from one corner to the other corner is just 50 plus 50, which is 100 steps. So that means if you do a simulation of some sort, and maybe there's some optimization, you only need to do 100 times, right? So we could probably do that. Yeah, because for every 100 times you want to at most, I mean, with a depth first search or something like that, you only look at each element of well, you look at each element of one time, and you look at the entire grid just once, or like once or twice, but of n, where n is the number of cells. So in that case, it should, after 100 simulation of a couple of depth first search, which are all linear in it was like 100 times 50 times 50 maybe times some constant. So that should definitely run in time. Um, yeah. So I think, though I should double check that. Yeah, I mean, I think that's my intuition on kind of the boundary analysis. Um, but I guess gotta make sure that. I mean, these. I'm just looking through the examples. There are 4 was built. Trying to understand the example 2 actually right now. I mean, I guess I get that you can build all around the 0, but you could do it in one turn. Oh, I see. Oh, maybe that's a little. What is a region? A wall can be installed between 2 adjacent cells. Okay. All neighboring cells in all 4 directions. Each day you can install. So we could build 4 walls at the same time. Let me. There are 2 contaminated regions. On the first day, add 5 walls. Okay. And then it splits. Oh, I guess in this case, you just do the inner wars, which I guess makes sense. Okay. Uh, in this case, you the affected area that affects the most. Okay. So I think algorithmically, I mean, just there's not a. I mean, it just tells you what to do. Okay. I mean, it's just a lot of coloring, maybe. But um, yeah, I think algorithmically, I don't think there's anything tricky about this. I think the tricky part about this problem is probably coding, and I mean, I guess that's always hard. But and just getting things correctly. But a little scared by the fact that there's so many downloads though. So I guess we'll see. think this. I think that's also a little tricky because you have to not count words on the boundary, but maybe that's okay. I don't get it though. So this one is 13 because you've built around this, I guess. Isn't that only 11? And then I guess the second turn it eats this up and then these up and then you just put one here and one here. Okay. All right. I mean, let's give it a go, I guess. What do you see though? All right. I mean, probably just figure out as we go. I don't think there's anything to analyze in terms of complexity. I mean, more than I already did. I think you just do a lot of depth first search and there are a lot of edge cases around those depth first search. And but I think in terms of timing, there's not that much time, so it should be okay. I think yeah. Like I don't think we're under like time stress, so it should be okay. Mm. It's just about structuring the code in a good way, I guess. Okay. Mm-hmm. I'm just going to code as much as I can and then kind of figure out how to recode it afterwards. But first, we want to count. No, I mean, I think we could just color. Yeah, we'll just color the the graph with a depth first search. Okay. Mm, maybe I need better naming though. Mm, okay. Oh my god, so bad at naming things. Struggling with the naming more than anything, but okay, cool. Let's just do this for now. Probably have to fresh this out a little bit, but add some conditionals later. But Maybe. Okay. Oh, they're not too good. Terrible at naming. Okay. That's numbers? Okay. I guess we didn't have to. We could treat it as a boolean, but okay, fine. This name is terrible. Okay. Yeah, I know it's C, but yeah. This is not. Okay. Something like that. I have to fix a few things. Okay. So that should color the graph. I know this is only one iteration, but that's printed out just so I could kind of visualize things a little bit. Just making sure we're still on the right track. Okay, fine. I'll just put that. Oh, hey, Piyush. How you doing? Just having some problems, hopefully. Oh man, what did I do? Hopefully I didn't miss that mess. I guess that was 10. Wow, it was 10 minutes ago. So I always got, you know, I get already intent in some form. Sometimes I was just typing a lot. Cool. Oh, boy, this each grid have different size. That would be sick. All right, I'm just gonna YOLO this for a little bit. Sad face. Oh man, I'm really proud of this. Also didn't intend to have INJs in here, but maybe that could be number. Okay, no, that's not good. These should be the same colors. Oh, oops. Yeah, okay, so that looks better. I wish I didn't choose -1 because it's slightly harder to look at. Okay. Yeah, so everything's working as progress. So now we have the kind of the different islands on this thing. Now we have to figure out which one finds the most uninfected cell the next night. Okay, and there won't be a tie. So I think that's just like a for loop, right? So okay, and then I guess we'll just do a count friend. Yeah, okay. I mean, maybe we'll rename it a little bit. Okay. How many colors are there? Maybe I should have put that somewhere. Should be C colors. Oh, I don't return C. Whoops. Well. So the number of colors will allow us to do stuff. Maybe. Yeah, by having a count on friend. And this could be in, I mean, 50 by 50, 2500. So, I mean, I guess not actually, but I'm just going to do that for now so I don't have to think about it. And I'm just going to without the global. Okay. This might be also. Yeah, I should have made this into a variable. I mean, a function. Whoa. missed something here. Okay, let's do this one. Let's go 0. Let's see. What's a -1? Okay, should be okay. Well, is that okay? Yeah, because doing the same mass, same island, you could actually find the same cell more than once. So actually, no, I can't do it this way. Actually, I think I have to do the inverse of this. Okay. If the color is that the name of the variable? So the tricky case is, and I mean, it's not that hard to imagine. It's just trying to figure out how to do it correctly. Is that for each cell, for example? Well, I guess just this one, right? You don't want to count the number in the cell in the middle 8 times, or 4 actually. But in any case, you don't want to count it multiple times. So I think that's just the thing you have to keep in mind. How do I do it? So given a cell, okay, let's say it's not infected. If it's not infected, then we look at the neighbors. And now we have to kind of dedupe these things. It's an easy way to dedupe it. How do I dedupe it? I mean, I guess I'll just, I want to do a lookup table. I want to do the colors. Yeah, I guess I'll just do what we've already done. Oops. Yeah, this is a mess. Right? What? What do I call it? Oh, count it. Yeah, okay. Okay. I think that should do it for one iteration, maybe. For counting, I mean. But oh, yeah, I took it out. We still have this print, so hopefully it'll tell me. Oh, well. Oh, that part's right, but I should also print out the front end. Okay, so 054, is that accurate? This one 1, 2, 3, 4, 5, and this one 1, 2, 3, 4. So okay, so I think that function is actually true. So now we have to get the max, which they promised to not have a tiebreaker. Maybe did I remember that right? There will never be a tie. Okay. So now I guess we install wars among this. Okay. I think this one's a little maybe massive, so there's going to be a lot of refactors in the future in theory. But well. Okay, now we're installing wars. Or oh, I guess we have to get the best one first. Let's resume. Okay. And now we actually install it by counting the number of rows. Okay. It is a mess. Okay, fine. Do I have to keep track of the rows installed? I guess colors is fine because once you're done with a color, that thing is done. I think once you're done with color, is it true that they effectively zeroed out? No, because I guess because then later on they could spread more. But so you have to use an. Okay, I'm glad I used 1 and 0s then. Maybe I have to make some modifications later. But okay. we used the same logic that we use in count, which is roughly. Okay, if doesn't matter which perspective we look at. I guess not. Okay, fine. If the color, if you go to typo though. This is what happens when you use a web browser to code. Okay. Even with some syntax highlighting, it's still kind of trickier than it should be. Okay. So keep the host sweeter. Okay. And doing some unfortunate copy and pasting here, but okay. Really need to modularize that. But okay. If you go to 0, then we create a wall. Okay. Maybe a lot of, oh my god, edge cases. And now we update the grid maybe. We just set it to some outworldly number. Okay, so that would be one iteration. Well, not yet. It still has, the stuff has to expand. So now they're wars against all these things, so never get expand and never expand into. Okay. Well, let's just almost click on submit. But let's see what happens now. Oh. Okay. Maybe that's good. I don't know. After you install the wars, you expand virus. Yeah, I think it's just every cell that is next to every cell that's next to a virus just expands, and we call it quarantine, but we effectively kill it because it cannot expand, or the ones that already exist. So if grid of objects equals 0, 0, 0. And oh my god, that's what I get for. Watch, there's a typo there. If yeah, okay. I mean, let's see what happens after that. Nope, didn't expand. That's actually interesting. Oh, wait. No, that should be good. So there's 1, 0, and it's next to it. Man. Well, that should be right, unless I got rows and columns backwards, but oh my god. Maybe it's a little late. Okay, cool. So everything expands. So yeah, okay. So I mean that does show kind of a bug, which is that you have to do it in the right order, or else you're gonna keep on like a cascading effect type thing. So set this to I just define this to be next to I don't know what's max time. No, they just say 3000 then. So let me just run. I mean, though technically it will not be right, but okay. What? Oh, because it's 3000. That's why the extra zeros. Okay. Yeah, whoops. Now we could just collect it. Cool. Okay, so that's what I think I expect after one iteration. So okay, so now I'm gonna ask, well, am I done? So I'm finished if there are no more viruses, I guess, or no more viruses eligible to expand. So yeah. We don't, nope. Otherwise, sure. I think that's maybe good. We'll see. Okay, so I mean, immediately returned correct for the first one. Let's kind of take a look at more questions and more examples. Time limit exceeded. Well, that's actually odd, maybe. I mean, I guess it's probably doing an infinite loop. Okay, let me just do this one real quick. I think maybe there's just some weird things with the formatting and the parser. Let's actually try that. Well, my answer's still wrong. So that at least it went in good time, though. I suspect this is the same thing. They should really give you examples that you copy and paste, but yeah, well. Okay, so it works for this one, which is good. But now I have to see why it doesn't work with this one. $23. Okay. Let's just put rows along the way. First, you expect 11. I think that's what you expect. And then after an expansion, that's here and here. And in theory, oh no, and here and here. So in theory, you just need to build a wall between here and here. Okay. So why did it ask for 12 instead? Yeah, there's a lot of code actually. 170 lines, probably bad ones too. But if I look at this one, we'll go up. Okay, let's just put it along the way. I think one thing that I always worry about is that the states are a little weird after each iteration. Because maybe I just don't reset the states in a clean way. But okay. Oh, do I not? Oh, that's right. The result is right, but the counting of rows is wrong. So okay. Wait, what? Oh, well, that's not stupid. Oh, that's not meaningful. Okay, 1, 4, 2, 4. That's reasonable. Okay, so all these things are kind of from the first one. So the first 11's legit. Oh, but then it tries to do it again. Why does it try to do that roll again? Let me set the roll. Maybe my colors are wrong. I mean, they have 2 different colors. But the second time they were all the same. Okay, I just probably have some wrong and wrong the color. Okay, nope. Did I changed it? The colors, or the grids afterwards. How did I come? Man. Okay, well, that was a. I knew I had something like. I mean, I kind of was looking for it, but I couldn't find it. But, so I guess that was just a silly mistake. But okay, that's the thing with keeping too many states and unlabeling them. Like, sometimes your base case change and you didn't even realize. Okay, let me just double check that stuff like this still works, and then I'll submit it. Okay. Cool. Fingers crossed. Time limit exceeded. Well, this isn't really a. I probably just have. Well, my for loop is just silly, I guess. Wait, what do. I guess I don't actually test for the case where you cannot save today, so that's just my bad. I think that was just like a very basic case. I don't know, just to make sure that okay, and basically you cannot save the verb, you cannot expand anymore. So I think I'm just put expand it. Oops. How do I do it? It's a little hacky. Let me just see what works first. Oh man, why did I put void? Maybe just second nature. Okay. That was a way they even tell you in the description, so it's kind of my bad that I didn't solve that one. Okay, cool. Wow. So that actually, I mean, minus missing the obvious case that they actually tell you to do, except for that wasn't on the examples. Got it on the first try. So cool. So that was a hard. I'm gonna try to do one more. I mean, this took me a while, about like an hour. Yeah, I mean, I think this one algorithmically, there's nothing too complicated. You just have to, it's. I mean, I did it with depth first search. You could use breadth first search similarly. I think it's just simulation. You have to do your boundary analysis so that you know when to terminate your process. Whether like a straight simulation is enough, and maybe if it's not, then maybe you have to do some fancier algorithms and to think about it. And once you did that analysis, and you're like, okay, maybe there's real one, then you can think about it. Then you can, just do a simulation, which is what I did. I mean, there's a lot of coding on this one. There's a lot to. It's really easy to mess up, and you've probably seen me mess up from here time to time. It's 167 lines, and it's not even 167 good lines. I have a lot of duplicated code here that I could clean up. But at the core, it is just depth first search, and it's just about kind of keeping track of all the special cases and unique cases that you might have to take care of. So that's kind of as an interviewee and as a problem solver. It's an okay interviewing problem. I think, again, similar to the previous problem, there's nothing too complex in terms of algorithms. You just have to be really careful how you define kind of a lot of definitions along the way, like the number of wars, or like what is a war, and how do you kind of when do you build one, and how does things spread, and so forth. But at the core is a simulation problem, and there's a lot of coding, and there's a lot of coding to make sure that in a way such that your edge cases are not that you don't want your edge cases, or your edge cases are taken care of in general. So again, similar to the previous problem, I would say definitely if I'm doing an interview and the person is if I'm interviewing the person for problem solving, then maybe this isn't quite the problem. But if I'm interviewing them for kind of just like programming, what do they call it? But yeah, just for programming, then I would definitely do this, like for kind of coding style. And then after this, I would talk about like, how do you clean it up a little bit, how to modularize, how to kind of, there's definitely a few things that are reused multiple times. And maybe maybe C is a little messy to do it, but like maybe using iterators or enumerators to kind of generate the next candidates for stuff. There's definitely a few things that we can do to clean up this code, but I think that's what I'm gonna. But I think for otherwise I think this is just very relatively straightforward. It's just about getting your depth first search to be very precise and to be correct and exactly what you need it to be, which is always a little challenge.